Let's talk a little bit about the verification of the solution for the exact equations.
Yeah.
Verification of solutions of exact equations. So the verification of these exact equation solutions is relatively simple. So let's take the example. For example, in the previously, I took the example 2. So we found the example was this equation, the original equation was e power 2y minus y cosine xy dx plus 2x e power 2y minus x cosine xy plus 2y dy. This was the original equation, and we found its solution to be, was x e power 2y minus sine xy plus y square is equal to constant. So in fact, it was an implicit solution. So for this implicit solution, if we want to verify it, so the simple method is to differentiate it with respect to x and y. So for this, we can use the partial derivative method for the integration. So for example, if we say that this is the solution function, so if we take this function as x is equal to e power 2y minus sine x y plus y square, and for the partial derivative of a function in two variables, so we can write it like this. So for example, if the function is in x and y over here, okay, so its partial derivative df will be equal to partial derivative of f with respect to x dx plus partial derivative with respect to y into dy. So applying the same method, what we can do is we can differentiate both sides of this equation with respect to x and y, and then we can very easily get the original equation. So let's see. So first, in this, if you apply this formula, then we first have to differentiate with respect to x, and then we have to differentiate with respect to y. So if you differentiate, this with respect to x first, so it will be x e power 2y minus sine xy's derivative will be cosine xy, and for xy its derivative will be y, and then for y square it will be 0 because we are differentiating with respect to x. So this will be the term with dx. Okay, so partial f over partial x is this term. Then next is the partial f over partial y term. It is equal to x e power 2y. So it will be differentiating with respect to y. So e power 2y, it will be e power 2y into 2. So x is 2y into 2 minus cosine of xy. Okay, sine xi is cosine of xy. So it will be yes, cosine of xy, and then for xy it will be x. Okay, and then for y square it will be plus 2y, and that will be dy. So this is the so we have differentiated it, and then equal to partial derivative of the constant, which will be 0 in fact. So now we can see that this equation x e power 2y plus y e, so we can compare this equation. So this is the same as over here, and over here it is 2x e power 2y is same here. It is x cosine xy is same here, and plus 2y is same here. So simply we have got the original equation. So in this way you can we can verify the equation, the solution very easily. So let's also verify the second example which we just solved, and we found the solution. So we found this solution, and in order to verify it, so what we will do is we will first take its derivative with respect to x. So for this first term it will be y square into 0 minus 2x, and then for this term it will be 2 cosine x. Okay, 2 cosine x, because this 2 will come out over here, it will be 2 cosine x. From chain rule, the derivative of cosine x is minus sine x. So this will be the whole term enclosed in with dx. Okay, for the second term we will take the derivative with respect to y. So it will be plus that is 1 minus x square into 2y, and minus cosine square x is equal, so because this is a function in x, so that will be 0. So this will be dy, and then derivative of 3, which is a constant, it is equal to 0. So now we can see that we can just a little bit simplify it. So it will be minus 2x, it will be minus 2x y square, minus 2x y square and that is plus that is equal to, yes, plus 2 cosine x sine x. Okay, that is dx dx, and then from here it will be 2y into 1 minus x square dy equal to 0. So if I want to express it in terms of so this 2 can be cancelled out, throughout cancelled out, so it will be xy square, it will remain as xy square, and then 2 will be cancelled out, so it will be cos x sine x, so it will be xy square this term minus cos x sine x, and if you can multiply divide it by minus 2, so then that will be plus, so it will be xy square, and that will be minus cosine x sine x. Okay, and then this term will be minus, so it means that it will remain as y into 1 minus x square. So in the end we will get the same expression like here. Okay, so in this way we can verify it.